So we'll go ahead and get started. Welcome to the HKS Energy Policy Seminar. I'm Joe Alding. I'll serve as the host today. Thrilled to have you joining us here as well as on Zoom. So as a reminder, we are operating in a hybrid format. And so when we get to the Q&A period, we'll be passing along the mics for questions. It's my pleasure to welcome Hélène Benveniste for her talk, Climate Mobilities, Empirical Evidence and International Policy Responses. Hélène is a Harvard Environmental Fellow. She received her PhD in Science, Technology, and Environmental Policy from Princeton University and earned an MS in Science and Executive Engineering from Mines Paris Tech. Her research focuses on two broad topics: human migration and inequality in the context of climate change and global governance of environmental issues. In her work, Hélène uses both quantitative methods drawn from environmental studies, economics, and demography, and qualitative methods grounded in political science. And one of the joys we have as faculty here is that we get to work with exciting young scholars like Hélène. So it's been great having her here for the past 2 years as a Harvard Environment Fellow, a regular attendee of this seminar. And now it's our pleasure to have you share with us the insights from your scholarship today in the seminar. Welcome, Hélène.
Thank you. Thanks, everybody. Can you hear me okay? All the way in the back? Okay. Well, thank you, Joe, for the kind introduction. It's been really wonderful attending this series for the past 2 years, and it's great to see many familiar faces in the room. So today I'm going to talk about climate mobilities, and I'm going to do that using one particular paper of mine, but I'm going to try and bring some more context to it, both before and after the paper. Before presenting the paper, I'm going to spend about 10 minutes kind of setting the stage and explaining what I mean with this term climate mobilities, so that we're kind of all on the same page. And at the end of it, I'll also spend a few minutes discussing the most recent developments on the policy front, in particular at the international level on these topics. And we should have plenty of time for Q&A at the end. So let me set the stage first. What do people think about when they think about climate-related migration? Well, if you look at the media, this is a selection of media articles that have come out in recent years on this topic. What you see is that they tend to have one type of focus on this issue, and that is one pretty specific mobility outcome, which is cross-border migration, and in particular, cross-border migration towards Western countries, the US and Europe in particular. But that's actually just one mobility outcome among many in the context of climate change. And when I talk about mobility, I very much also include e-mobility in it. And that's because both migration and e-mobility are two sides of the same coin. They're both not always the result of an actual desire, either to move or to stay. They can be a choice, so they can be closer to an involuntary consequence of a given context. Now, we know that what immobility can be a choice, we also know that resource constraints can limit the ability to migrate. And that's because migration, and in particular cross-border migration, is costly. It requires resources, whether economic resources or social resources, knowing people where you're going, or health even resources. Really, those who move tend to be those who are able to do so. And this is true for any type of migration. Now, the effect of climate variability and change on this is quite complex. It can play out both directly and indirectly through various channels. And depending on the context, climate variability and change can either induce more migration or more immobility with various degrees of agency in the mobility outcome. So these pictures try to illustrate this. If you start from the top left here, displacement is often the main outcome that people tend to think about when they think about climate-related migration. But as you see, it's not the only one. The picture on the top right is meant to illustrate the fact that migration is already a widely used adaptation strategy to climate variability and change. So you might think, well, with increased impacts of climate change over the coming decades, we can see perhaps an increase in the use of migration as an adaptation solution. And then the two pictures on the bottom illustrate cases of immobility, with the one on the bottom right highlighting instances of people being able to adapt where they are without having to move if they don't want to. For instance, in agricultural areas, that can look like switching crop growing practices. And then the picture on the bottom left here illustrates the fact that what climate variability and change often does is that it depletes resources, and in particular, in some of the most deprived areas. And so perhaps with increased climate change, we might also see a decrease in the number of people who are able to move. And so all these different mobility outcomes are going to result in very different risk levels for the populations involved. And so if you want to think about, given all these mobility outcomes, one way to define what climate mobilities are, you're going to see it's pretty broad. And here I'm going to use the definition of a slightly different term, environmental migration, which has been coined back in 2007 by the International Organization for Migration. What they say is environmental migrants are persons or group of persons who predominantly for reasons of sudden or progressive change in the environment that adversely affect their lives or living conditions are obliged to leave their habitual homes or choose to do so, either temporarily or permanently, and who move either within their country or abroad. So it's a very broad definition. And between this and the slide prior here with those 4 pictures, I'm hoping that this is kind of going to give you a helpful conceptual picture for how to think about climate mobilities. But what about climate mobility in practice? What does it look like and how do we know it? Well, a way to think about research on this topic, it's often to kind of be grouped in 3 sets of broad questions. The first set of questions is going to ask some version of how has climate affected mobility so far. Those types of questions tend to be answered using empirical retrospective case studies. Then there's another set of questions which is going to ask what will happen in the future, and in particular, in a future with more and more climate change. And there often the point of those studies is to do projection exercises of migration patterns over several decades. So a long time so as to be able to include increasing effects of climate change. And that's going to be able to be done using some kind of modeling tools. And finally, the last set of questions is about what is being done about it. And this is where we get closer to policy solutions. And we'll discuss at the end that there is not a whole lot that has been done yet on the policy front on this topic. So today, the paper I'm going to talk about is squarely situated in the first category. But as I mentioned, I'm also going to talk about the last category at the end a little bit. So what has been going on so far, and what does the empirical evidence tell us? So in order to talk about this, I'm using a paper that I'm currently writing with Peter Hybers and Judd Proctor, who are both at Harvard here at the Department of Earth and Planetary Science and at Hughes. So climate mobility, if you think of perhaps some recent empirical, like real life examples of how climate variability might have affected migration patterns, perhaps one of the most salient examples has to be Pakistan, which, as you recall, last summer suffered really devastating floods following a very heavy monsoon season. Those floods displaced over 30 million people, so really very large numbers. So in those types of very extreme events, the causality between the weather or climate event on the one hand and then the population movement on the other is rather obvious. It's not very complicated to figure out what happened, but it's not necessarily the case for all the manifestations of climate variability and change. Look, for instance, what happened in Kenya in 2009. Here on the left-hand side, I'm showing a map of Kenya with its administrative districts. The ones that is highlighted here in light green is called the Eastern District. It's a rural area where a lot of people are going to depend on agricultural and pastoral activities. And here in the bottom corner here, oh, sorry, the pointer doesn't work here. Sorry for the people at the back of the room. It's Nairobi, the capital city. And on the right-hand side, I plotted 3 different quantities. At the top is the migration rate plotted from, sorry, is it me that's making all this noise? Sorry about that. Okay, you know what? The solution is going to be, sorry about the people on Zoom. Take that out, take the jacket off, and it's going to work out better. And then the hair. There's a lot going on. So going back to the plot. So the first one is the migration rate over time between this rural district and the capital city. And concomitantly are plotted in red the maximum temperature in the rural district. And then in green below is the soil moisture in that rural district. Soil moisture is a helpful indicator of water availability, which is going to be particularly helpful for characterizing agricultural activities here. So a quick note on the migration plot above, you see that we don't have values for migration in this corridor for every year of the sample here. So this is going to be a disclaimer. When it comes to migration, it tends to be pretty challenging to have kind of a full data set, fully balanced panel data, in particular in context of lower income countries. But beyond that, the descriptive point I wanted to make here is about what's going on in 2009. which is shown with the vertical dashed line here. What you see happening in 2009 is first a high spike in temperature, so a heat wave, then a low spike in soil moisture, so a drought, and concomitantly a pretty high spike in migration from that rural area towards the capital city. And when you read government reports about that event, what they explain is that that heat wave and drought induced pretty bad shocks on agricultural production, and so quite a few people left that area to go to the city in order to find ways to diversify their income. So it's a very plausible story for how weather might affect migration patterns. But the question becomes really, does this weather-migration relationship hold in other contexts? Well, the response to that question depends a whole lot on the study that you look at. Here I'm showing a figure that's taken from a meta-analysis that came out a couple of years ago. What Hoffman et al. Did was that they put together all the existing quantified estimates of environmental change on migration. They did that for within-country migration and also for studies that look at cross-border migration. So let me walk you through this plot. Here, there is a series of horizontal box plots. Each box plot is for one specific study that they looked at. So they looked at about 30 studies. And each box plot is constituted of all the estimates of that particular study. And they're weighted with the more precisely estimated, so the more statistically significant being weighted more. And then in order to standardize all those different studies across one another, because those studies don't use necessarily the same measure for migration or the same environmental factor, what they do here, the x-axis is going to be the standard deviation change in the migration outcome following a one standard deviation change in the underlying environmental variable that is being looked at. The thing you want to look at is whether those box plots are to the right or to the left of the big zero solid line here. If it's to the right, it means environmental change induced an increase in migration. If it's to the left, it means it induced a decrease in migration. So the thing I want you to take away from this plot here is that the empirical literature highlights a whole lot of variation in the overall migration response to environmental factors here. So you can ask, why do we see those different effects? And if you think back to the conceptual framework that I gave at the beginning, you know, those four pictures here in the quadrant, is it the case that those differences across studies are actually reflecting different underlying differences in the agency of individuals in making their migration decisions, that is, in their level of constraints in making those decisions? So this is what this paper is trying to focus on here. But because it's really difficult to directly observe the level of constraints on migration, the proxy we're going to use for it here are going to be demographics of individual migrants. Why demographics? Well, the migration literature tells us that things such as the age or the education level of people are going to be key determinants of people's ability to migrate. And so that's what we're going to use here. So the question we want to answer is to what extent those differences in demographics are going to help explain those differences in mobility responses to weather that we're seeing in the empirical literature. And let me give you a quick snapshot of how we go about this. We go about this in two steps. The first step is going to be about identifying a causal effect of weather on migration. For that, we use classical panel fixed effects regression models. The type of data we use for migration data, we're going to use data stemming from census because that's going to give us information on individual level demographics. We're also going to use temperature and soil moisture data. I'm going to get to it in a minute about how we build that. And then the second step is going to be as follows. Once we have set the identification with those fixed effects, we're going to use the identifying variation, so the data with the fixed effects removed, to do cross-validation exercises. What is that going to allow us to do? It's going to allow us to test the model's performances out of sample. And we're going to do that to use that to do two things. First, that's going to help us address concerns related to overfitting the data. And second, that's going to help us choose our favorite model's functional form. And I'm going to try and convince you of the importance of this second step here by doing that second step on existing studies. So some of the ones from the meta-analysis that just mainly use the first approach here. Okay. So let me share a quick overview of findings. Here are some spoilers. What we find, first of all, is that the models of weather effect on migration are actually going to perform quite poorly as long as they don't have in themselves some individual level information on migrant demographics. What I mean by performing poorly is that the other sample performance is going to be null or negative in those cases. However, once we start including individual level information on people who migrate, we do find that weather helps predict migration, both within country and across border, but largely not by itself, mainly when we allow that weather effect on migration to differ depending on different dimensions, and in particular, depending on individual level characteristics. Age and education are going to be very important here. So what is that effect of weather on migration? Well, it varies a lot. Depending on the case, we find weather acting either as a push factor to migration, and in other cases, acting as a resource constraint on migration, with the latter explanation being particularly prevalent for cross-border migration. And so to us, what this suggests is that the local and individual level context is going to be really key for understanding the weather migration link here. That's concerning because I'm going to discuss at the end that the current institutional landscape is actually currently not quite set up to cover this multiple range of mobility outcomes that we're seeing empirically here. Okay, so let me get into the gist of it now. I'm going to start by talking a little bit about the data. The migration data that we use comes from a database called IPEMS International. It's a database managed by the University of Minnesota, where what they do is they harmonize all kinds of census data from many countries. It's a really cool data set. In it, we have information both on migration within country and across border. However, we're going to treat those two types of migration entirely separately throughout the paper. And that's for two reasons. There first, the fact that those two types of migration tend to be quite different in nature in terms of the people involved, other type of barriers to moving. And second, in the data set itself, those two types of migration are coded differently. So we're going to treat them separately. For within country migration, the data is collected at the subnational administrative unit by the country where the migration is taking place, so the country of census. And the information you get is the current location at time of census, and then the prior location 1 or 5 years before, depending on the country. We infer from that the timing of the migration, and so that's data that's available for about 62 countries. Now, for cross-border migration, that data is gathered at the country level by the country of destination. We have 26 destination countries. There, the information we have is the exact migration year, and we're going to have information on the country of residence, which is the country where the census is taking place, and on the country of birth. And here we're going to assume that that's going to be the origin country, which is an assumption. So the data set is not like perfect in all aspects, but the one benefit that it really has is that it gives us individual level information on migrant demographic characteristics. We have the age, the education level, and the sex. So that's what we're going to use here. Now, in terms of weather data, we use data on daily maximum temperature and on soil moisture. The temperature data comes from weather stations. The soil moisture data is derived from satellite observations. There's a process to be done here because that data is available at the daily scale and at the gridded scale geographically, so very spatially disaggregated. But we're only going to be able to use it at the level of the migration data, which is at best subnational level and every year. And so we have to average it both temporally and spatially. To average it temporally, we don't just want to just average the values because we want to be able to capture the extremes during the year. So we're going to use polynomial expansions of the daily values to get unknown linearities. And then in order to spatially average it, we're going to use population density. So we're going to capture more the weather at origin locations in places where there is more people, simply put. The last point I'm going to make here is that we expect the effect of weather variables to vary depending on the baseline climate in that location. So think, for instance, a dry anomaly is going to have much more of an effect in an area that's already scarce for water than in an area that has plenty of water. So we're going to control for that. So let me show you what the data looks like. This is a plot here for the average within country migration rate, averaged over the time of observation for all the countries for which we have data. So this is what it looks like. We also have information on migrant demographics, as I said. So these pie charts describe the education, age, and sex here. For education, we have 4 levels. So primary education not yet completed, primary education completed, secondary education completed, and then higher education. For age, the groups that we use are under 15 years old, 15 to 30, 30 to 45, and over 40, and then 2 categories for sex. You can do the same plots for cross-border migration, showed on the right here. The 2 things I'll point out here is one, if you compare the 2 maps, They use the same scale. So you see that the migration rate is much higher within country than across border. That's a known fact. And then if you compare the two sets of pie charts here, you see that the within country migrants are less likely to be higher educated, and they're more likely to be children and among the older adults than cross-border migrants. That's also something that is well known here. Let me show you what the weather data looks like. The average temperature value over the period of observation here for the countries for which we have data on with the country migration. Nothing surprising, higher temperatures around the equator and the tropics. Same plot for the soil moisture value, drier values around the Sahel and the Sahara, higher values, for instance, around Southeast Asia. And finally here, the different baseline climate zones that we use a classification that is called the Köppen-Geiger classification. And just to show you here the names for those of you who are in the back and who might not be able to read this. So in orange, we have the tropical areas. In yellow, the dry cold. In red, the dry hot. In green, the temperate areas. In purple, the continental. And then in light blue, the polar areas. We have very few observations for that one, so we're not really going to use that. Okay, so now let me get back to explaining in a bit more details how we go about this. I mentioned that we use an approach that is in two steps. The first step is going to be about the causal inference. What we use here is that we're going to want to identify the effect of weather on the migration of a particular demographic group. So here, the unit of analysis here is going to be the proportion of people from a specific demographic group that's going to move from a given origin to a given destination. And we're going to compare this unit of analysis to itself over time as a function of weather variables. So let me walk you through this equation. The outcome variable here, it's the ratio of the number of people who move between origin O and destination D at time t with the set of demographic characteristics Z. Z is a vector that includes three indicator variables, age categories, education level, sex. And then the coefficients of interest here are the betas, the series of betas that are going to describe the nonlinear effects of temperature T and soil moisture Sm at origin location. We use a cubic form here. We want to be able to capture nonlinearities of those weather variables. Now, the main thing I want to discuss is this series of fixed effects that we use, which is in the second line here. We use a pretty rich set of fixed effects for our empirical design. So the first one we use is an origin destination demographic fixed effects. So that's going to allow us to account for time invariant characteristics of a specific migration corridor for a given demographic group. So for instance, the distance between origin and destination or the existing diasporas. We're also going to use your fixed effects to account for location invariant temporary shocks, think for instance, financial crises, and then origin specific linear time trends. Okay, so this is the baseline empirical model. Now we want to be able to explore how this weather effect on migration is going to differ across two important dimensions. The first dimension I mentioned is the baseline climate. So we add to the baseline model a set of interactions of an indicator variable K, which describes the climate zone with the weather variables. And then the second dimension of heterogeneity is going to be those demographics where we're going to interact the weather variables with one or several of the three demographic variables, age, education, and sex. And so here we're going to test a series of models. There's going to be different combinations of those three sets here. So that's the first step, the causal inference part. Now, the second step I mentioned is going to be to use the identifying variation. So we have the data, we take out the fixed effects, and based on that, we do cross-validation exercises. How do we do that? Well, once that data is deemed trended, we cut it randomly to 10 folds, and then in turn, we're going to use 9 folds to train the data, to train the model, and we're going to test it on the validation data, the 10th fold. And we're going to do that in turn. The performance is going to be computed as the R square on the validation data. We call it the within R square because it's once the fixed effects have been taken out. We're going to get an uncertainty distribution for the R square by using a bootstrap approach. And again, what I want to make clear is what we use this cross-validation for. First, we want to make sure that we're not overfitting the data. So the test is going to be that we want the out-of-sample performance to be at least positive here. And second, we want to figure out which model we should choose, which one fits best the data. So we're going to look at all those combinations of equations 1, 2, and 3 that I showed, and we're going to look at the one that has the highest performance, the one that explains the largest share of the variation, the residual variation once the fixed effects have been taken out. Why do we think it's important to do this cross-validation part here? Well, we want to make sure that the effects that we're finding are actually robust, that those are robust effects of weather on migration. And let me show you the first result here, which is the first thing we did, which is we went back to this meta-analysis and did cross-validation on as many studies as we could find from those 30. And so among the 30 studies so far, there's only two that we could find where we're able to fully access the data and the code so that we could fully reproduce the results and do cross-validation on it. So we're really grateful to the authors for that. The first study studied both within country and cross-border migration. The second study only looked at cross-border migration. Both studies did not have individual level information on demographics, and they both found a significant effect of high temperatures on migration, although you see here that the effect of temperature on migration is not the same in the two studies. So on the one hand, it's true, they looked at different data, they looked at different countries, they did find different results. On the other hand, it also hints at the level of complexity that might be taking place here. And so what we really were interested in is to what extent those estimates would be robust to the cross-validation step here. So this is what we found. Let me walk you through those plots. A and B here are for within country and cross-border migration of the first study, and C is for cross-border migration of the second study. For each, we tested the main specifications that were used by the authors. And what I'm showing here, so the box plots are the out-of-sample performance, and then the single dots above are the within sample performance of those weather variables. So you see that the within sample performance is always positive. That's not surprising. Those studies do find significant effects of weather here, of temperature in particular. What we didn't know was whether the out-of-sample performance would be negative. And what we find is that basically across all the specifications, that performance is either null or negative. And it's not just those studies. When we do that exercise with our migration data, but without taking into account individual level demographics, we also don't find any predictive power of those models. Now, once we include individual level information on demographics, what do we get? Well, these are results here for within country migration. What we did was we tested the series of specification. T is temperature, S is soil moisture, and then different combinations of interactions with the baseline climate, and then age, education, and sex. What we find here is that weather does help predict within country migration, but not so much by itself, much more when it is interacted, those weather variables are interacted with various quantities. In particular, the baseline climate brings a pretty important increase in performance. And then the best model is going to be the one that allows the weather effect to differ both across baseline climate and across age and education. Those are the two demographic characteristics that seem to matter. Sex does not seem to matter a whole lot here. This is not to discount the important role of gender on migration patterns. What might be going on here is that the gender effect is very context specific. In some areas, it's going to be more the women who move. In some others, it's going to be more the men. And overall here, we're not able to capture that. But we do see that age and education matter. And in order to convince you that there is really something going on here, on the very right, we did a placebo run of the best performing model. What we did was just to shuffle randomly the weather observations, and we don't find any performance here. We do the same exercise for cross-border migration, similar results. The two differences are first, the baseline climate zone doesn't seem to be doing much. It's bringing a lot of noise, so we're not going to use it. And second, you might have not paid attention. This was within country migration. Sorry, I'm going back to that for a second, but just to show that the numbers that you see remain still quite small, even in the best model here, we were only able to predict about 1.5% of the residual variation once the fixed effects have been taken out. These numbers get smaller for cross-border migration, but still the best model is still the one that is going to use both age and education interactions. So the takeaway for us here is that the local and individual level context is really going to be key for understanding these weather migration mix. So what does this relationship between weather and migration look like? Let me start by within country migration. Remember that in that case, the model that worked best was the one that allowed the weather effect to differentiate between climate zone and age and education. So we're going to plot those response functions for each of those categories. This is, for instance, what's going on for people who are younger than 15 and have not completed primary education in areas that have a tropical climate. This is what the curve looks like. What about other people in those areas? Well, here I'm plotting the same. I'm hoping that you can see on this projector. So the little plot that I was showing was this one, and you can plot 15 others with increasing age categories and increasing education categories going up. The thing that you see here is that the one effect you seem to have is that higher educated people tend to move out more under high temperature. That's not so much the case for other demographic groups here. So what does this suggest? Well, this result is kind of consistent with the story where you think that weather is going to act as a resource constraint on migration, potentially for the people with less resources, in particular here, the people with less education, who are going to not really change their migration behavior, whereas the people with more education are going to be able to move out. Now, this is an interpretation that does not hold everywhere. If you look, for instance, at what happens as a response to soil moisture in areas that have a dry, hot climate, which is where we expect soil moisture to matter most, this is, again, the figure here for the people who are younger than 15 and have less than primary education completed. Here, by the way, I forgot to mention, apologies. The y-axis is the change in the migration rate, and then the x-axis is the soil moisture here. If you look at what's going on with other groups, for other groups here, you see less differences across demographic groups as a response to soil moisture, but still, there is still a slightly higher migration response for droughts, so for low levels of soil moisture here, for people who are younger and less educated. So here the result is more consistent with a story where you think of weather as a push factor on migration, where people with potentially less resources are going to be pushed out here, whereas other people not quite as much. If you look at what we find for cross-border migration, this time we're going to look at results differentiated by age and education only. And in particular, here we find effects of temperature. What you see is that the response to high temperature differs quite a bit across demographic groups, with the lower education and younger people seeing their migration decrease across border with high temperatures, and we don't see that effect for other groups. So again, here we're back in that story of potentially weather acting as a resource constraint on migration for the people who might be having less resources here. So what do we take away from all of this? Well, to summarize what we found that weather does help predict migration, both within country and across borders, but largely not by itself, and definitely not without including individual level information on migrant demographics. So you end up with pretty complex models, but we do think that those levels of complexity are necessary to actually fit the data that we're seeing. How does weather affect migration? Well, depending on the case, either as a push factor or as a resource constraint. Both explanations appear valid for within country migration, just depending on the location. The second explanation, though, it appears really more valid for cross-border migration. So what does that suggest? If you look back at the conceptual framework and those 4 pictures that I showed at the beginning, what this suggests is that local and individual context is going to be really key for figuring out in which corner of this figure we're going to find ourselves into. That's a finding that was also already put forward in more of the qualitative literature, kind of based on more ethnographic methods, where people do document the fact that individual level characteristics are going to matter. Here, what this study does is that it kind of brings a more quantitative layer of evidence to this claim. So the local and individual context matters here. And so what that means is that policies that are aiming to address this climate mobility question really are going to want to address the full range of mobility outcomes and not just one particular outcome. So let me take a step back from this paper in particular and look at what's going on in the real world. And in particular, I'm going to focus on what's going on at the international level. So the most relevant international institutions for this issue are probably the ones shown here. So there is the UN High Commissioner for Refugees, the Sendai Framework for Disaster Risk Reduction. There is also the UN Global Compact for Migration. For those of you who don't know what that is, it's a non-binding agreement that was signed in late 2018 and it proposes a kind of holistic framework to think about all types of cross-border migration, regardless of the cause. Then, of course, the UN Sustainable Development Goals, where about 2 of the 17 goals directly refer either to migration or to climate. And finally, the UN Framework Convention on Climate Change. And I'm going to talk about that more in a minute. But the first point I want to make here is that at this point, all those institutions really only focus on people, on mobility, on migration, to the detriment of immobility. That is, they largely focus on people who move and not so much on people who don't. And moreover, a lot of those institutions only focus on cross-border migration, not within country migration. So arguably, they don't quite cover the full range of mobility responses that we're seeing here empirically. And so because the status quo of the governance framework is not perhaps quite optimal here, it might be helpful to kind of get back to more fundamental principles and asking perhaps more normative questions, questions like what is owed to people whose mobility ends up being affected by climate variability and change. And this is something I'm working on with a political philosopher as well. Let me just walk you through 3 of the normative approaches that have been proposed here to deal with this issue. The first one, you're probably very familiar with it, relates to refugees. The refugee term relates to a legal status, but you also know that the Refugee Convention is based on a binding normative principle of non-refoulement, which prevents states from sending back individuals to their origin location if that were to put those individuals at risk of persecution. Now, you see that this principle really kicks in only once the movement has taken place, and that movement needs to be in the form of cross-border migration. So you see that it doesn't quite cover the full range of mobility outcomes that we were talking about. The second set of approaches relates to humanitarian obligations. There, the idea, of course, is that a country's duty to provide aid is going to be understood as a generous or as a charitable extension of that state's responsibility, really based on that state's goodwill. So it's very ad hoc. And again, it also takes place afterwards, so kind of more of a reparative manner rather than a preventative manner here. The last approach I wanted to talk about relates to loss and damage. Loss and damage is something that we've talked about a couple times in this seminar series in the fall. You remember what it is it relates to the impacts of climate change that can neither be avoided through mitigation nor adapted to through adaptation. The reason I'm bringing up loss and damage here is that because the one way that migration and mobility is addressed in the climate regime is as part of the loss and damage mechanism. And in particular, there is a task force on migration and displacement that was put together in 2015. That task force is hosted in this Warsaw mechanism for loss and damage. So currently, at least conceptually, the way the mobility question is tackled as part of the loss and damage pillar is probably broader than the 2 other approaches, but it still very much is a responsive approach, reparative approach, and does not propose a preventative take at this point. So it does seem that all existing approaches have important shortcomings. But I don't want to conclude on that. I do think that there are perhaps some more recent development that might make things perhaps a bit more helpful. You remember what happened last November at COP27 in Sharm el-Sheikh in Egypt. Their migration and mobility were not really at the forefront of conversations, but what was loss and damage very much at the forefront. You remember that countries adopted a fund for loss and damage. And while adopting it, they used the language that really directly referred to the mobility question. And let me quote exactly what they say. They say the fund is aimed at targeting developing countries that are particularly vulnerable to the adverse effects of climate change. The fund is meant to fill gaps in the current landscape of institutions. So that can relate to the gap that I was just describing. Gaps including related to displacement, relocation, migration, or the need for climate resilient reconstruction and recovery. So it does seem that it's kind of a broader approach than what has been taken so far. And I think it's likely that we're going to see the mobility question become kind of a growing part of the conversations in the climate change arena, which I see as something to be hopeful about. And with that, I'm going to stop here. I thank you for your attention and looking forward to questions.
Thank you, Hélène. Let me ask 2 questions to get things started, and then I'll pass around the mic. First is on the destination side and trying to think through some of the institutions that govern migration among your destination countries, which I think the way you described the sample is likely to be larger and more developed countries. And I think about this, say, in the context of the United States, where we've seen changes in immigration policy and immigration attitudes, and certainly seen then changes in immigration flows over time. So, wondering what you might be able to do to bring in some of the insights about either changing rules on immigration from some of these destination countries, or anything else that could help us better understand, in a sense, sort of another side of the constraint. I mean, you describe resource constraints as affecting the ability to move, but one could also imagine that some countries that could be a destination at one point in time may not be at a later point in time because of changes in the destination country policies. The second about your methods. And so I'll say this, and then I'd invite like Jim Stock to correct me afterwards. But to sort of think about this use of this cross-validation technique to try to sort of, in a sense, you're evaluating some of these to see how well do different models perform. One could go a next step and say, you're really going to do a model search through this method. Like right now, you've got this kind of cubic in temperature and you have a cubic in soil moisture. You have no cross products. And it seems like that's just sort of taken as like, we're going to run this model and then test over different kinds of interactions with climate zones and demographics of the immigrants. And so the question I have is, and I guess I get a little concerned when I look at the ends of some of those figures, knowing that that cubic is having a lot of influence on the shape on the ends of your figures, is whether you've thought about going the next step and just trying to sort of automate like a large model search. There's no real reason why we think these functions are cubic. We just think they're probably nonlinear. And whether you've thought about it, maybe you've already tried to do this some, and maybe what you're showing us is like the cubics tend to perform best. That's why we're focusing on these, but get a sense of where there may be opportunities of taking this second step, sort of another step further, and really doing a larger search over potential models to help explain this kind of behavior.
Yeah, I'll answer the second first. The We have tried other. We haven't done a proper automated model search here. We have tried other functional forms. In particular, we've tried quadratic forms, and we've tried a more flexible one, restricted cubic splines. The quadratic forms perform less well than the cubic, which is why we choose the cubic. The cubic seem to perform about as well as the restrictive cubic splines, who put less constraints on the end. But because they're a bit more tedious to manipulate and they performed as well, we stuck with the cubic. But we haven't done so far a fully automated search, and that's a limitation for sure. On the first question, the migration policy that can also play out as a constraint. That's absolutely the case. Specifically in this data set, it's true we haven't done like a full search of what are the migration policies that have changed perhaps over the time period of the observations and how that might have affected. One way I have explored this question is in previous work when I was doing more modeling exercises, so kind of projecting ahead, in the future, what migration patterns might look like in futures with climate change and under different assumptions of migration policies. And in particular, the one thing we were finding is that restrictive migration policies really seem to limit increase the exposure of vulnerability of people, because they seem to limit the option for more exposed and vulnerable populations to be able to use cross-border migration as an adaptation solution. So kind of a restrictive constraint here that we're seeing clearly when we're doing modeling exercises. It's not something that I've tested in this setting particularly.
Open for questions.
This is very interesting, and I'm wondering about the impacts of growing, using as a proxy for all kinds of other things in society, economic wealth, or growing economy, and people becoming richer. And I'm not even sure what the sign is here of this, but I'd be interested in your speculations. I'm getting the impression from this is that the first order guess would be there are many things that are affecting this problem, and weather isn't very important. And weather's not the same thing as climate, but climate isn't very important if you're getting richer. And so a lot of the implications are is that migration is less of a problem than I might have thought before I walked in the room.
Yeah. So a couple comments on that. It's true that weather and even climate is a small part of why people move. They're excluding, by the way, these are here we're really focusing on some kind of longer term migration trends. We're not really capturing very short term displacement, coming after, important disasters or that kind of stuff. So putting that aside, where there is a very obvious direct link and very important link between the weather or the climate event and the migration pattern, it's true that overall migration decisions are based on things that are largely not environmental, and so the environmental factor is going to play a small role here. I think two considerations still are important. Is people tend to come at this thinking that the environmental factor is going to play out in one direction. What we're seeing is that it's really not the case, and that's something that's, at least as far as I know, maybe people have different opinions in the room, has not really percolated yet to the policymakers here. And I think that really needs to be something that is well understood in the policymaking community. The second thing is that we know that cross-border migration in particular is strongly driven by income levels of people, but also income differences across countries. And that's where perhaps climate change might play an indirect effect. And in a lot of those modeling exercises, what people do, myself included, is that you don't really see a direct effect of climate on the migration patterns, but because climate affects different locations differently, both the levels and the absolute levels and the relative levels of income are going to change, and that has a strong effect on overall migration dynamics. Does that make sense? Yeah, no. What we're seeing is that the sign overall is not clear, and I would even argue that the sign overall is not what we should care about. What we should care about is who ends up being affected one way or another. But the point that I'm trying to get at is the fact that a person moves or not doesn't tell you all that you need to know about to what extent there is perhaps a need for policy intervention. It doesn't tell you to what extent you know the migration was seen as something that was positive or something that was negative. The push factor versus the resource constraint. That was the point that I was trying to make. And so here I think it's really important again to push beyond the sign question, beyond the number question, but focus more attention on the who, on the which conditions.
Hi there. Thank you so much for this presentation. I had a question about the data.
Yeah.
And obviously, we can only analyze what we have data on. And displaced populations in particular are really hard to get accurate data about. And when we're trying to nail down the unique demographic characteristics, the more vulnerable you are, the harder it is to get those data. I was curious if as you went through these data sets, you came away with recommendations or sort of major data gaps that you think need to be addressed and what those look like.
Yeah, that's a daunting question. It's a very important one. The data on migration in particular is really difficult. It seems to be kind of, so what we have access here is whatever is registered in the census. So it's not clear to what extent, depending on the country, I'm not even sure, whether people are just focused on people who legally migrated, whether, some illegal migration is in there as well, and you just don't have that information. There's other limitations in the terms of we're not going to capture short-term migration there. We're not going to be able to figure out whether what we're capturing is return migration. Think about, flows between Mexico and the US. Often there's a lot of back and forth, or definitely they used to be before the policies at the borders were, have become this rigid. And here it's not that we're not able to capture return migration, it's that we don't know if what we're seeing is return migration. So there is definitely limitations to these types of data. Again, I think it really depends on the type of question you want to ask. What you really care about is who is moving. You want to find a way to have individual level information on people. And if you were going to think about very different types of data sets, such as, I don't know, mobile phone data or that kind of stuff, to kind of follow people, more closely at a much more high resolution temporal scale. There, you're not often for private for privacy considerations, you're not going to have information on who those people are, for instance. So there's a whole set of questions that you're not going to be able to ask that way. So I feel like we just have to choose the type of data with respect to the question we want to ask, acknowledging that definitely there is huge limitations in all those. Hi.
I find it really interesting, this idea of using the lens of migration and how it exposes the fact that we also need to look at those that aren't moving and the why of that. But I wonder from a policy perspective, if you're looking at all the right tools, in the sense that somebody who is looking at policy of those that don't migrate may be looking more adaptation and other sort of societal factors and policy tools. So I'm curious how does looking at using the lens of migration inform policy differently for those that don't migrate, I guess is my question. What would be your sort of observation about the significance of it from a policy perspective?
Yeah, that's a really good point. The fact that people who don't move often, in terms of policy responses, that's not really framed in a migration question at all. The reason I try to insist on this is because, at least in my view, maybe you would concur, the way the climate migration link has been talked about in policy spheres has been overwhelmingly in a narrative of a lot of people are going to move from global south countries to global north countries, kind of the whole conversation being framed very much from the perspective of destination countries. And that has resulted in kind of a atmosphere where what people care about is the people who are going to move across borders all the way there, and that's it, and not so much the people who stay behind or who move less. And there is, I think, an important consequence of that framing in terms of the policy prioritization, in particular in the climate change conversation arena, which I think is not necessarily reflective of the actual needs that we're seeing in the empirical reality, which is why I was insisting on it. You're right that the mobility question can be also leaped into the adaptation framework. But so far in Paris, it's not the case. The adaptation question does not address this at all, which is also something that might need to move in the future. Yeah, the adaptation piece is pretty important. Let me answer the first one. First, the question of the channel through which those weather variables might affect migration. And there are various channels that you can think about. And actually, when we started this project, we really wanted to focus on the agricultural channel. And so we really started looking at ag yields and differences across irrigated versus non-irrigated areas. And what we ended up with was a bunch of results that didn't seem super consistent, specifically on the agricultural channel, with some results pointing to one direction that agricultural seemed to matter, some others completely the opposite. So we became a bit puzzled with all of that. And so we kind of went back to the results that to us made the most sense, which were those ones with the demographic questions. If I can address kind of the broader literature on that, the channel question is still in its infancy, as far as I can tell. In the meta-analysis that I showed, that is just a couple years old. There's not that much more that has been done since. Largely, what people do is some version of temperature and precipitation, and that's about it. The channel is still not quite explored. Then there is a huge literature on how those variables might affect agricultural production. That's for sure. But the link between the two is not quite made fully with like an abundant literature yet.
Thank you. I have two questions. First, about the channels. So in terms of the data set, do you have occupation or industry for this individuals? I think that might be a good proxy, that some occupations or industries are more locally binded, but the other are more flexible to move. So besides the education, that might be something to test. The other thing is like the response to the change in the weather or precipitation. So in my mind, I think it's more of like you have an outlier or like abnormal changes in some of these variables that kinds of change are leading to a migration decision in the end. So, but in the current specification, it seems more like a continuous specification of the differences. And sometimes you're testing, like if you change a little amount of the temperature or precipitation, how the migration behavior are responding to that. But do you think it's possible to test like some extreme shocks or like hazards related to these things and that impact on the migration patterns? Thank you.
Yeah, so the second question, it seems that what you're asking is to what extent a threshold model might make more sense here. It's definitely an option. Remember that we do have to, we ended up with this pretty, I don't know how I'm going to respond to that. We end up with a pretty continuous response function here also because of the way we also have to average spatially and temporally the whole data. We don't have disaggregated enough information on migration to pair those kind of very extreme events with the direct migration shock. But that's something that we're probably going to explore more in the future, kind of more bin distributions. On the first one, whether there is data on occupation and industry, there is data on that on very few of the census. And so it's always the trade-off. You can ask more out of less, less countries. And so we kind of were attached to have a pretty big sample of countries in there. So we really ended up focusing on education as a proxy for all of that. But it's a limited proxy in some ways.
Thank you. So, Hélène, you noted that you have taken a sort of a separate approach to doing cross-border migration and within-country migration. And so I have two questions about that. One is, are you exploring how, for lack of a better term, just the size of the origin country matters for whether or not within-country migration is an option? Right? Like I can imagine in India, there are a lot of options. I can imagine in Uruguay, there aren't many options. It's just small.
Yeah.
And it is, and so as a result, I wonder if there's ways you can try to examine just what are some of the opportunities to really migrate within country. And as a result of that, while you've kept these as separate, do we think that there are contexts where within country migration is a substitute for cross-border migration?
Yes. So the first part of your question is something we need to explore more for sure. To what extent the size of the origin is going to affect the possibility to do within versus cross. On the second, it's not even that it is the case that within country can substitute for cross-border, but it's even more than that, is that often within country comes before cross-border. So people are going to move within country, they're going to move to the city, and then after they're going to move across borders. They're rarely going to move. There is often like several stops along the way, and that's something we're not able to capture well here. Again, because the census data is not really built at first for migration purposes. So this is kind of a secondary use for it. And so we're doing what we can, but it's definitely true that in practice, that's definitely something that would happen.
Hi. So at the end, you spoke a little bit about the international mechanisms that govern the responses. And I was curious, since you mentioned that some of the funds might be transferred through loss and damages, um, if a country wants to make a claim for money for adaptation or to support migration response, like what level of evidence will they need to bring? And what does that conversation look like? Do you have any thoughts on that? Like, would you need to basically have a very robust model like this to and more data to make that claim? Or yeah, so what are your observations of the conversations at that level?
Yeah, so I guess the question you're asking is to what extent the attribution question really is going to matter for funds distribution. I think that's a question that can be asked more broadly within the climate change arena, not just for the migration question. My sense, I don't know to what extent it's practically, politically even feasible to use the whole attribution science to distribute funds. I'm not quite sure it's possible without the migration question, even just like for some kinds of impacts. I do think that when it comes to migration, it's an even greater layer of complexity on it because people move for so many other reasons than just migration. My sense, if we're gonna make the funds attribution dependent on that, it's not gonna work out. One of the things that I'm working on with these other colleagues is to try and figure out a framework where the basis for fund attribution would not have to do with the specific attribution of the migration event to the climate change. There are ways you can think about that. But I think if that's the barrier you put, you're not going to make much progress for what policies need actually to be implemented.
I listen to this and I come away with the idea that this is a very complex issue and that this political rhetoric that we're going to see, millions of refugees going across borders is uncertain and maybe not going to be the case. But the one that troubles me is if you look out in the future and you look that climate damages are going to get more severe over time, you look at sea rise where you simply can't live in the same place, whether you like it or not. What the little data that I've seen show that there's a lot of migration within the country, within the region. So you move from your village, which you can't really move the whole village and sometimes because it's too expensive, to the largest community there where you think there might be jobs. But there's very little government policy to help those larger communities. And so if you look at in-country migration as an issue, what are the policies that you would recommend that countries ought to think about?
Yeah, so there's a lot of work that people do. So that's not something I have focused too much on, but there's a lot of work that people do on buyout programs and that kind of stuff. For instance, if you think about sea level rise, a point I want to make there is it's not so simple. It's not because you have sea levels rising that automatically you're going to have people moving out. Actually, there are a couple studies that have come out in recent years that are really interesting on that. The way sea level rise manifests itself is more and more frequent flooding, but over a period that's pretty long. And so it's not clear that people would move right away. And actually, there is a study that's really interesting on Bangladesh, where because the main economic centers are on the coast, you actually see with city of rise more and more people moving into the city because a lot of people are moving for reasons that have nothing to do with the environment. And instead of having less people in the city, as it gets more exposed to city of rise, you get more people into the city and so more people exposed in the end. So I think that's also something to think about in terms of policy designs, which is why things like buyouts might make sense. I wouldn't dare saying that I have a strong opinion on whether that would have any practical success in terms of buying out whole communities. Often what you tend to see is that people who have the means to sell their homes and leave do, and then some people who maybe have waited too long, then their homes are not valuable anymore, and then they're not able to move out. That's also a dynamic that we see. Just a quick comment on the political rhetoric point. I think you're really right that that political rhetoric is not quite supported by the evidence. Kind of the way it started, at least from the first studies on climate migration, were using kind of an exposure approach, where the numbers that were computed were not how many people would move, where it was much more how many people would be exposed, and then assuming that those people would move, which is a big, big difference. And that's actually not what we're seeing empirically. So those numbers, those millions of numbers were more kind of drawn from those types of studies. And what we're seeing playing out, I think that's a discourse that we saw a lot in Europe in particular in the mid 2010s, where a lot of people would talk about, migration as being this face of climate change in Europe, with people coming into Europe as being kind of the main impact of climate change. What we've seen as a response of that politically has not been more action on climate change, it's been more of a restriction of borders, which is a very different type of policy response and has very different consequences on both the people at origin and the people at destination. So that was just a comment on that.
Thank you. Thank you so much. Great presentation. I have a brief question. How do you think the climate change also reshape this economic structure that also generate labor mobility? So you emphasize on the international immigration, climate immigration, or domestic climate immigration from this climate disaster adaptation. How this impacts on this domestic labor mobility? Thank you.
Yeah, I don't know what I can say on that in any precise fashion. Just to say that you're absolutely right that climate change is gonna restructure the way economic activity is pursued, and that obviously would also have an effect on migration down the line. I don't know that I would see the other way around being as important a factor, meaning migration really changing as much the economic structure. The structure of the economic activities at origin and destination, but for sure we are going to see ripple off effects of climate change on economic structures, for sure.
Okay, so before we wrap up, let me remind you we will meet again at noon next Monday. We'll be back across the hall. We'll have Weila Gong of the Belfer Center and Joanna Lewis of Georgetown University presenting a paper on China's coal transition. And finally, please join me in thanking Hélène Benveniste for her presentation today. Thank you, Hélène. That was great.
Thanks for your questions.